I'm scared, guys. We're dividing decimals with decimals. Not to worry. Today I'm going to teach you a strategy that will work whenever you're dividing a decimal with a decimal. You don't need to fear because your strategy is going to get you the answer. So here we go. So stop right here. Take a moment. If you have not watched the video on using the traditional algorithm to solve division problems with whole numbers, stop here and go back and watch that video. Okay? All right. So today we're learning the traditional algorithm dividing decimals with decimal divisors. Oh my gosh. Not to worry though. You'll be fine. Okay. All right. So we have to rewind our brains back to when we were learning about fractions and back when we were dividing fractions, not with whole numbers. We were dividing fractions with fractions. Okay. So remember we did some interesting representations, and when we represented those, we discovered that when you divide a fraction with a fraction, your quotient is actually larger than both of your fractions. That's the strangeness of dividing fractions with fractions. Yes, but in fact, decimals are fractions. Fractions are decimals. Decimals are fractions. So that same strangeness, whenever we divide a decimal with a decimal, we're going to see the same thing. All right? So let me bring you back. I'm going to remind you about how to divide fractions with fractions. Then I'll connect that to our traditional algorithm. Okay. I've written here a division with decimals problems. 0.8 or 8/10 divided by 0.4 or 4/10. And now I'm going to convert this back to fractions just to show you what's going on. Okay, so I've written down here 8/10 divided by 4/10. Okay, that's the same thing. We just turned them into fractions. And we remember that when we are trying to divide our fractions, we can't just divide regularly. We have to use the flip and multiply strategy. So here's what we do. We go down here. Our divisor is the one that we flip. We flip our divisor. Then we go ahead and multiply our numerators. We get 80. We multiply our denominators, we get 40, we get 80/40ths, and when we simplify, oh my gosh, we get a whole 2. 8/10 divided by 4/10 is 2. That's wacky. It's bigger than both my dividend and my divisor. But remember, that's the strangeness of dividing decimals and fractions, okay? All right, so now I'm going to teach you the traditional algorithm. I'll go through that process, and then I'll do one additional practice problem, okay, just so you get the picture. Okay, so let me set this up, and I'm going to use the traditional algorithm, all right? So my 0.8 is going to go inside of my division bar, and my 0.4 is going to go on the outside, just like this, okay? Now the first problem we run into is, oh my gosh, again, going back to the top. The problem is we have a decimal divisor, so we need to fix that. So I'm going to teach you a trick that will work so that you don't have to work with the decimal divisor, and it all has to do with powers of 10, okay? So instead of dealing with a 0.4, we can actually deal with a 4, okay? We're going to use a power of 10. So what I'm doing is I'm going to use a jump strategy. I'm going to actually jump my decimal over here, so instead of dealing with a 0.4, I'm now dealing with a regular 4. I did one jump. That's the same thing as multiplying times 10. It's a little trick you can use. Now, if you want to get an answer that's actually the real answer, whatever you do to your divisor, you have got to do to your dividend. Otherwise, you're not going to get the right answer. So I did one jump here. I must do that jump inside here as well. I'm going to do one jump to the right. And again, that's going to make this a whole 8. All right? So now instead of dealing with a 0.4 and a 0.8, I'm now dealing with 4 and 8. Much easier problem now. But instead of saying, oh man, I'm going to be happy, it's going to be easy, I'm going to go ahead and I'm going to put my decimal up here, just like we usually do when we're dealing with decimal division and the traditional algorithm. We line up our decimals, okay? So we're going to use just regular 4 divided by 8, or 8 divided by 4. 8 goes into 4 2 times. 8 goes into 4 2 times. We multiply and get 8, subtract, and find that we have no remainder. Our final answer is 2. Now, that's exactly what we got when we did the turn it into a fraction strategy. That means we have one strategy which is now checking our long division strategy. So we are good to go. We can trust our answer 2. All right? Okay, so that was one step. All you got to do is, again, just going over this, you move your decimal in your divisor until you have a whole number. So if it takes 1 jump, that's fine. If it takes 2 jumps, if it takes 8 jumps, whatever you do, turn it into a whole number, okay? And then whatever amount of jumps you are doing in your divisor, you're also doing to your dividend. So if you did 4 jumps here, you're going to do 4 jumps here, okay? All right, so that's one. I'm going to do one more practice problem, and then I will end the video. Here we go. This time we're going to do 36 hundredths, or 0.36, divided by 0.06, or 6 hundredths. I'm going to go ahead and set this up. My 36, or 0.36, I'm sorry, goes into the division bar, and my 0.06 is going to go as my divisor. Now, right away, you can see we have a problem. It is hard to deal with these stinking decimals. We got to get rid of them, okay? So, this time, going back to the powers of 10, we're going to need to multiply this by 100, or, in other words, do 2 jumps in order to turn it into a whole number. So watch what I do. I'm multiplying times 100, or I'm doing 1, 2 jumps, okay? Now we're not dealing with 0.06 or 600ths. We're dealing with just regular old 6. So remember, whatever you do to your divisor, you do to your dividend. We do 2 jumps to the right, just like we did here. Now we move our decimal up to its new location. Okay. Now we're dealing with regular old 36 divided by 6. Okay. We know that 36 goes into 6 times. We subtract. Our answer is 6. Our answer is 6. Okay? All right, so hopefully that video made sense. If you need to, you're welcome to go back and watch it. Until next time, toodaloo.